Welcome to Teja Statistics. In this class, we are going to learning about the types of errors in testing of hypothesis. There are two types of errors. They are type 1 error and the type 2 error. What is a type 1 error? The error of rejecting the null hypothesis when H0 is true. Okay, so rejecting H0 when H0 is true is called the type 1 error. If it is already true but you are rejecting, so it is an error. So this is called type 1 error. The probability of committing the type 1 error is called the size of the test, or it is denoted by alpha. Alpha is equals to probability of type 1 error. So rejecting H naught when H naught is true, you can see that. Okay, probability of rejecting H naught when H naught is true, it is denoted by alpha, and alpha is belongs to the rejection region. So that is symbolical representation. X belongs to W, or we can say it as omega also sometimes, under H naught. Okay, the function of in the form, that is likelihood function they are using here. Alpha is equals to the integration over W or omega L naught into dx. So what is L naught here? What is W here? The W is a rejection region, and what is L naught? It is a likelihood function under H naught. Next, it is called the probability. The producers is also in SQC. Next, coming to the type 2 error. What is any type 2 error? The error of accepting H naught when H naught is false. This is a big mistake which is already false, but you are accepting the statement is okay. That is called the type 2 error. So the probability of committing type 2 error in generally it is denoted by the beta. What is beta? Beta is equals to the probability of type 2 error. Accepting H naught when H naught is false. That means the probability of accepting H naught when H1 is true. The probability of accepting H naught, the H1 is true. So the rejection region opposite is called the acceptation region or acceptancy region. So symbolical representation is probability of X belongs to W bar such that H1. So under H1 the likelihood function will become L1. So what is our function here? So that is beta is equals to uh, integration of W bar or omega bar L1 into dx. So it is easily denoted here or remembered by the following table. Okay, reject H naught, accept H naught when H naught is true. Reject H naught when H naught is true is type 1 error. There is no error. Acceptance when it is true. Okay, coming to the next one, rejecting H naught when H naught is false. Okay, that is also be the correct decision. Accepting H naught when H naught is false, that is type 2 error. Next, let's see some more definition of the level of significance. The probability of type 1 error is known as the level of significance of a test. It is also called as the size of the test and size of the critical region, which is denoted by the alpha. Generally, the prefixed as the 5% or 1% level of significance, the alpha is equals to 0.05 and 0.01. LOS is how to decide the critical value. The cutoff values of the that provides us the critical uh, area equals to the 5% or the 1%. Okay, it relates the trueness of the conclusion. Okay, so that is called the confidence intervals of a given test. Okay, so This alpha is indicating what is the probability of committing the type 1 error. Okay, if H naught do not uh, reject at level of alpha, that is 5 percentage level, then a person will confident that the conducting and concluding the statement about the H naught is true with the 95 percentage of assurance. But even then it may falls at 5 percentage chance. There is no cent percentage assurance about the trueness of the statement made for H naught. See one example. Among hundreds scientists, each draw a random sample, use the same test statistic to test the same hypothesis H naught, conducting same experiment. Then 95% of them will reach to the same conclusion about so H naught, but still 5 of them may differ or different. Okay, next see the definition of the power of the test. Probability of rejecting H naught when H naught is false, that is 1 minus beta, is called the power of the test. 1 minus beta is nothing but 1 minus the accepting H naught when H naught is true. So that is the rejecting H naught when H naught is true. That is a correct decision. Okay, 1 minus beta is denoted by x belongs to the rejection region, no. So that is W or omega, we can call it as under H1. Okay, 1 minus beta is denoted by uh, integral over W L1 into dx. Next, the most powerful test. This is a very important definition in the testing of the hypothesis. Yes, let us consider the problem of testing a simple null hypothesis H naught. Theta is equals to theta naught against H1. The theta is equals to theta 1. The critical region is W, is the most powerful critical region with the size of alpha. So for testing these two, uh, it if it satisfies the following condition. What is the condition? The first condition is probability of x belongs to W under H naught, that is L naught alpha formula or the integration value they are writing. Next, and it is more than the any another critical region with the size of the another power of test, that is P of x belongs to W such that H1 is always greater than or equals to probability of x belongs to W1, that is W1 under H1. So where W1 is any other critical region satisfying the condition 1. This is how, that is 1 minus beta is always greater than or equals to 1 minus beta 1. Okay, next the test function. What is a test function? Let x equals to x1, x2, x3 and so on, xn be a random sample from a population with the PDF of f of x comma theta, where this theta belongs to the omega or such that let x1, x2, x3 and so on, xn be an observed sample of x. Okay, the probability of rejecting H naught x equals to x is known as the test function or a critical function, and it is denoted by phi of x. Reject h naught at 1, accept h naught at 0, and or the reject h naught where 0 less than r less than 1. There are two types of test functions. They are non-randomized and randomized test function. What is a randomized non-randomized function? Non-randomized function in the sense there is no distribution functionalities. Okay, where the x follows, it does not tells you. Okay, and coming to that, another definition of the random test. What is randomized test is in the sense, so where there exists a distributional functionality and the limits, then it is said to be the randomized function. Okay, you can see the definition. Next, the very important theorem, that is Neyman theorem, Neyman Pearson lemma, so which we are going to see in the next session. Thank you.